Question 4.1. For 1 mark, give a reason why angle TSK is 90 degrees. Simple. TMR runs through the center of the circle. It is the diameter. The diameter subtends an angle of 90. Question 4.2. For 2 marks, calculate the gradient of TS. The gradient is rise over run, or 7 minus 2 over 3 minus 5, or 5 over minus 2, or minus 5 over 2. 4.3. For 3 marks, what is the gradient of SR? The gradient of SR is minus 1 over the gradient of TS, because the two lines are perpendicular. Therefore, the gradient of SR equals 2 over 5. The equation of SR is then y equals 2 over 5x plus c. And we know that this must go through the point S with coordinates 5, 2. Substitute in and solve for c, you get 2 equals 2 over 5 times 5 plus c, or 2 equals 2 plus c, therefore c equals 0. So the equation is y equals 2 over 5x. Question 4.41. For 2 marks, calculate the length of TS and display it in surd form. From the equation for the circle, we have that r squared equals 36 and 1 over 4, or r squared equals 145 over 4. Therefore, r is equal to the square root of 145 over 4, or r equals the square root of 145 over 2. Now, tr, the diameter, is 2 times the radius, or tr equals square root of 145. Question 4.4.2. For 3 marks, calculate the coordinates of r. We are given that the equation of the circle is x minus 9 squared plus y minus 6.5 squared equals 36 and 1 over 4. This means that the coordinates of m are 9 and 6.5. The points T and R are now symmetrical around m. Therefore, r equals 9 plus 9 minus 3 and 6.5 plus 7 minus 6.5, or r equals 15 and 6. Question 4.4.3. For 3 marks, calculate the sine of r. Sine is opposite over hypotenuse. So sine r is TS over TR. Now we know the length of TS to be the square root of 7 minus 2 squared plus 5 minus 3 squared. TS is the square root of 29. And from 4.1.1, we have that TR is the square root of 145. So sine r is the square root of 29 over the square root of 145. Question 4.4.4. For 3 marks, shows that B can be represented as 12a minus 29. From question 4.4.2, we have that the coordinates of r are 15 and 6. The gradient of TR, MTR, equals 6 minus 7 over 15 minus 3, or minus 1 over 12. Now the gradient of TK, MTK, is minus 1 over MTR, as they're perpendicular by definition of the tangent. So MTK is equal to 12. Then the equation for TK is y equals 12x plus c. And when we substitute this into the coordinates of t, then 7 equals 12 times 3 plus c, or c equals minus 29. So the equation of TK is y equals 12x minus 29. Substitute in the coordinates of k, a, and b, and we show that b equals 12 times a minus 29. Question 4.4.5. This is for 6 marks, so expect a rough one and make sure that you show your workings. Give the mark a chance to give you marks. And whatever you do, don't leave this question blank and invite a 0 out of 6 mark. If TK equals TR, calculate the coordinates of K. From 4.4.1, we have that the length of TR is equal to the square root of 145, and the length of TK is equal to the square root of a minus 3 squared plus b minus 7 squared. Square both sides, we get a minus 3 squared plus b minus 7 squared equals 145. Now the algebra gets very laborious, so check it carefully. Expand both terms and gather the likes, and you'll come to 145 a squared minus 870a plus 1160 equals 0. Divide the equation by 145 and you get a squared minus 6a plus 8 equals 0. Factorize this, a minus 2 times a minus 4 equals 0, or a equals 2, or a equals 4. Now substitute these values of a back into the equation for tk at point k, and we get b equals 12 times 2 minus 29, or b equals 12 times 4 times 29, b equals minus 5, or b equals 19. And for the case of this diagram, KAB is going to be K2 minus 5. Now if you got that, congratulations. It's by far the toughest question in the paper. This is the separator of the 100% from the distinctions. The hook on a question like this is to keep going. Each question and each section builds on the previous one, and if you get it wrong, keep the correct logic. You can still pick up close to full marks even with some wrong answers.